Hi, this is Barry. I'd like to do a deeper dive on AI security, but before that, let's quickly introduce all the terms that we're going to be using. I'm going to explain what is a model, and we're all talking about agentic nowadays. What is really an agent and knowledge bank, and also workflows? I'll explain what these are by showing you some examples. So let's first get into models. There are so many different models out there. Say, for example, ChatGPT is one, Gemini and Llama. They are all trained with a very large amount of data. They have capability of providing answers. They can make predictions and do classifications, lots of capability on their own. And we can interact with them through like a chat interface. You can send some answers. Let's say, for example, 9 minus 1 equals. So that interface will send a question to our model. Right here, I'm using Mistral, and it's going to provide an answer that says the answer is 8. Now let's double the outcome. I was thinking again, and trying to get an understanding, what did I really mean by saying, let's double the outcome? And now it just says, I'm not sure what you mean by double the outcome, because it just doesn't have the context of this whole entire conversation. Every question is a brand new question to this model. So how do we make it have some memory? We can actually add a component called memory here. And this is part of the agents, right? So now we're getting into the agentic space because they can interact with the environment and they can make some autonomous decisions and leverage some different tools. So let's now try, ask the same question again. 9 minus 1 equals to what? And of course, it's 8. We already know that. Now with the same answer, let's double the outcome. Let's see if it knows what we're talking about. Now, it has the whole history of this chat within this session. So now it knows I'm trying to double the outcome, which is 8, and now it provides the right answer, which is 16. Now it has memory. It can be more relevant. It can answer questions more intelligently. But let's say, for example, I work for a law firm, and I want to ask questions about my customers and the cases that I'm working on right now. The model does not have knowledge of what I'm dealing with. This is why businesses are building their own AI applications and also giving it access to knowledge base. So those knowledge base could be a structured database, say, for example, a SQL database here, and we can easily attach it as a tool to our agent. And within that database, we might store some important information like my customer's information, right? Like the cases I'm working on. There could be also vector databases. We'll talk about those in a second. I'll show you an example. But let's say now if I have a database, what can we do? What's Barry's last name? Let's say. So now, of course, the model itself does not know what's my last name, but now it knows, oh, there's a database. So maybe it will now go and ask the database. Now you saw that flash a little bit. Now it was querying the database, and we can see the actual query. It's just saying select last name from user where first name equals to Barry. And now it's able to provide us an answer that Barry's last name is Yuan. Let's say what's Barry's phone number. Same thing. It's just going to do a query into the database and tell us the phone number as well. So we can see that it was able to query the database and look for my phone number, and it was able to provide my phone number right here. Okay, so this is a basic agentic AI example. This is a structured database, but let me quickly show you a vector database as well. All right, this is an example of a vector database. Vector database store data in a vector numerical representation, but it looked very similar. We have a model and we have a memory, and we also have a vector store attached here with an embedding AI model. And we can also send information to this vector store by just dropping files. We have a process also, I'm showing you here, to actually extract metadata from that file, and with an AI model's help, and then it's going to tokenize, basically break that those metadata into small chunks so that we can store in our vector store. And then when you ask a question here, it can go and query the vector store and provide you answer with the context. Now we can chat with our PDF files, Word files, or Excel sheet, whatever that we provide to this vector store. Now let's pivot into AWS Bedrock, which is a platform where we can build an AI application on AWS. So very similar concept. It provides a lot of different models. It has a whole catalog of models here. And then we can request access to these different models. And then we can build agents. With the agents, we basically give it a name, right? And now I chose one of the models. And then also attach it to a memory, like the example that I just showed you. And then also a knowledge base. So over here, I'm using a vector database for the knowledge base. As you can see, this is my vector store. And all I'm doing is basically look for files in an S3 bucket. And then I'm going to ingest the file, whatever I throw in that bucket, and then store in the vector store. So as you can see, I had pulled some of the, a file out already, and it's already stored in the vector database. So now we can interact with this agent. Let's do a test here and say, what's Barry's phone number? And it's going to pull the vector database and tell me Barry's phone number is this. We can also look at the trace by hitting this show trace. That's going to show us all the different steps. What did it do to get an understanding of the question? And now it's retrieving all the reference information and then provide an answer. So it's going to show you like all the different steps. Okay, quick review. This is basically how we build AI applications. We have vector database, we have application data, and we select a model, maybe a open source foundational model, and then we feed it with data, and we might even train it a little bit, right? But then in runtime, it's going to query our vector database and provide answer to our users. And a lot of things could go wrong here. For example, the vector database could get poisoned, right? So we can inject malicious data into it. The model itself could potentially have backdoor as well. There are more than 100 models in Hugging Face today that have backdoors built into them. So, and you're deploying those models right next to your sensitive information, your data center. So that's a big risk. And also there could be potential data poisoning that poison all the data that you leverage as well. So lots of things could go wrong here. As a user, I can potentially extract information by doing prompt injection and take information that I'm not supposed to, or get AI to do things it's not supposed to do as well. There are lots of examples like how do we poison the data set. Actually, it doesn't cost that much. Under $60, you could get a expired domain that are hosting some training data that poison the model. That's more than enough. Every time that we fine tune the model, sometimes the guardrail goes away a little bit as well. On top of that, we've done some research that basically shows the AI threat landscape. It's quite detailed, explaining all of the potential risks, but looking at our environment here, as you might be thinking, there could be some sensitive information in there. What is Barry's SSN? Now you can see AI is potentially leaking sensitive information to users, which potentially are outside users. In the next section, I'm going to introduce our AI defense solution, our capability to help to discover all of your AI assets, detect the risks that are involved, and also help to provide real-time protection and guardrail around your AI. Stay tuned for the next video. Thank you.